So today we are going to do this very interesting question called is palindrome. So obviously in general palindrome structure you just check if the actual string given, so let's say the string given is equal to the reverse of the string. How we do that? We just say s, so s is the actual string and the reverse string is all the elements like this. So this is the reverse string. So we just say this, and this will take O of n space, extra O of n space for storing the reverse list, right? But when you run it, this is just basic palindrome check. When you run it, we get a wrong answer. Why? A man, a plan, a canal, Panama. What? Why we are wrong? So it says after converting all uppercase letters into lowercase letters, this is one case, and removing all non-alphanumeric characters. So what is the numeric alphanumeric characters? Alphanumeric characters includes letters and numbers. So one thing we can do is we can just generate a new string called answer and we can say that answer is dash dot join character. If character dot is alpha is alphanumeric, if alpha is alphanumeric, and then we can just do lower, right? We can just do lower. Join C if C elf num should be working. Why isn't it working? Uh, yeah. So one mistake we did there was one mistake we did there was join C if C is an elnum, but for what? What is C? C for C in S if C dot is elnum, right? So character in string. What is C? C is a character in the string. And we do this, we have not done this. We have to do this answer equal to answer is to s plus 1. We do this and we submit it. This gets submitted. This will get submitted, and this is obviously a good answer, but it takes a quite a lot of memory, and there is another way. So it takes quite a lot of memory. Why? Because you have to generate the answer string, right? What if we use two? What if we did a very interesting thing that we have just learned, which is two pointers? So left, comma right. Uh, one second. Left comma right is equal to 0 and len of s minus 1. So while left less than right, so while left pointer is less than right pointer, we just check. First, we just make it lowercase. So s equal to s dot lower. This is important. So if s of left is not so is alphanumeric is not alphanumeric. So if left is not alphanumeric, we go to the next character in left. So you just say left left plus equal to 1. Similarly for right, let's see b if right s dot right is not alphanumeric, so we say right minus equal to 1. We get one closer. Else if s of left s of left is not equal to s of right, right, then it's obviously at that point it is obviously false, so we return false. False. If all this is satisfied, then we return true. Is L num? Okay, it's not is alpha. Is L num? Is L num? Let me just. So obviously we don't use this thing. We use not. We use not, and we run it. Not as root right, not equal to return false expected. Syntax error expected. This thing. Okay, what is this expectation? Else. Oh, okay, it will be elif. Else does not tick. Uh-huh. We have to go while left less than right. Yes, while left less than right. So for all the cases and not s dot left is enum, it will be and not s dot left is enum. It should work. While left less than right, less than right, and not s of right is enum, is enum. If s of left, yeah, this should work. It's getting TLE. Let me. We have skipped a very important thing. Uh, if s of left equal to s of right, then also we have to do left plus equal to 1 and right minus equal to 1. So it is the case where it is equal. So these are the cases where in right there it's not a alphanumeric character, then we go back. In left, if there is not a alphanumeric character, we go back and we run it. And I think this will submit. Yes. Bada bing, bada boom, bada bap, bap. So we've done this. What we did, the first option was fairly easy. We just created a string where we removed everything which is not alphanumeric, and then we just checked the string as if it's equal to the reverse of the string. But in the second option, we took two pointers. If it's not alphanumeric, we take the left pointer one place ahead and the right pointer one place back. And if the left and right both are alphanumeric characters, we compare them. If they are equal, then well and good, we increase the left pointer, we decrease the right pointer. If they're not equal, then we obviously return false, that yeah, if this at this point it's not equal, then it's false. And if the whole uh, loop goes ahead and it's not false yet, then that means obviously it's a palindrome and we return true.